Hello. In this short tutorial, we will look at how to operate our GNSS R&D receiver platform, also known as RAD, Rapid Application Development Model Portus AH-R16U3. U3 simply denotes USB 3 connectivity. This configuration means 8 antenna inputs can be used at the same time. The unit has 16 internal RF tracks, and the antennas are connected through 8 M-type inputs, the upper row for L1 and the bottom row for L2 and L5. Depending on your setup, the platform can be used as a dual-frequency differential receiver, 3-antenna configuration, CRPA, controlled reception partner antenna, or as a multi-frequency signal antenna front end. This unit is a SDR front-end designed to operate together with our RMS software receiver. USB 3 cable to connect to the control PC. We have a cable which allows to switch this USB connection on and off, which is very convenient. And we have a number of splitters which allow us to use these inputs in various configurations. This unit is configured to a specific input, which we will look at the moment. So first of all, let's connect it to a control PC. A USB cable is asymmetric, so we need to be careful how we insert it. It should be inserted with this split faces down. Then the other part of cable can be connected to this switch, and then we need to connect it to power, which is on the rear panel. So it's here, and there is a connector which currently we use because we have here some additional functionality. So we have actually AC/DC 12 volt here instead of standard 5 volts. So in this case we can use 12 volt connector, and also we have some other connectors, some of them provisional, some of them intended for operation. So this one, for instance, is digital analog to digital ADC clocks and sampling clocks, and this is GPS discipline, basically 10 megahertz and 1 pps, GPS based 1 pps out. And we have one of the sensors intended to be connected to inertial measurement unit, and specifically we have this one adapted for this Honeywell unit, which one can use it, for example, with a standard evaluation kit setup, which is used with a USB cable, but we would like to use it with a receiver for various research related to tight and ultra tight coupling. And in this case we have, again, this is a provisional because it's fairly short cable, but it has a M12 connector. So, and we have here an adapter which allows this data to be transmitted and coupled with the receiver. And to connect it, we need to put it so it will be here, should be and we tie it up here, and then we have on adapter we have a connector, so we put it together. We can also use this to tie it up with the screws. Okay, so this IMU is connected, and now we can go and look further in this unit operation. So we put it switch on. When we put the switch on, we have a fan starting to operate, and we have a power indicator switched on. This is a RAD 1 power indicator. So we have this number of N connectors. For this particular unit, we have 3 GPS connectors, because we use a SMA type of antenna. We need an adapter, so adapters are included. So we have so this is the 3 GPS antennas, and actually this is a single GPS, and single GPS for attitude determination and RAD and such, and this one is a dual frequency antenna L1, L5, so we can have here, for example, GPS, S-bus, Galileo signals, and here we have Navic L5, GPS L5, and Galileo E5A. And because the hardware is adapted specifically for specific signal, so we actually, for this antenna, we need a splitter. We can use this type of splitter, 4-way splitter, or we can use a configuration of 2-way splitters, because we need to connect 4 connectors to one antenna. So this is a 1, 2, and 3 antenna, and third antenna has actually 4 inputs. Well, we take one we already have connected, so we can connect this splitter. Let's push a bit further. If we can, we should be able to push it a bit further. Yeah. Okay. Here we go. Okay. And this can be connected So this is for GPS signal. This is for NAVIC and L5, GPS L5, because they have a different RF tracks, and this one is for timing related applications. So this one has its own track. If we don't use those applications, then we don't really need to connect this one. What is important here is that the lower level of N connectors, they have internal DC blocks, so we can connect all those directly, and we use this L5 antenna, and we can connect it to this connector, and these two connectors we connect with different two antennas. So we have three antennas altogether: single frequency to this input, other single frequency to this input, and dual frequency to this input. And again, this is one of the possible configurations of this unit. What is very important here, that the upper level has no DC blocks. So we can connect, and we need has 5-volt output to power up amplification of signal in this antenna or in another antennas. So this one has 5-volt outputs, and those have DC blocks, so we can connect all to this one antenna. We cannot use splitter on these connectors or any other connectors on the upper level, because upper level has no DC blocks. If we, for instance, would like to, for some reasons, to have it connected through a splitter, if for example for test purposes or some other purposes, then we have to put additional DC blocks. Then we can, so we need to make sure that only one DC through is connected through the output, and all the upper levels are DC through, and all the bottom levels are DC blocked. Now we can, the other side of this cable is attached to PC. So why the cable is convenient? Because we always need to make sure that we switch on USB second after we switched on the power. So the power always comes first, because it has O6O, and it must be warmed up a little bit, maybe at least a couple minutes, better 5 or 10, even better. It depends. If it's, so if for some reason you switched off, then you can use this conveniently to switch on and off without removing the cable. When we switch it off, we have this LED up and this green, which means the O6O is up, and this locked. The internal system is PLL is locked fine. It's indicated by this green LED, and this LED indicated that the unit is successfully ready for operation, programmed, etc. Then we can start operation by clicking the run button on the PC. Also, what is included here is this small dongle for software activation, and that is all. So you can basically on this unit you can have other configurations as well. For this particular unit, it also programmed to have this output for the second NAVIC signal. So what is possible here? So again, we assume that those connected to one antenna, those connected to another antenna, and these two inputs can be connected through the splitter to another dual frequency antenna. Let me show it. So we can connect this one. It's not. It's a rigid one. Wait a moment. Okay. So we can connect this one basically now turn it so it will be more, it will have more space for the demo. So now we can connect this to this splitter. Then we can connect this splitter to one dual frequency antenna, this splitter, for the sake of this splitter, to, let's see, let's take this one to another dual frequency antenna, and finally